Hello, and welcome to my lecture on the Mini-Django web server. So why did I build this Mini-Django web server? Well, the first part of my Django for Everybody course is always about getting students to understand the nature of Django. If you know how to use Django and you know how it works internally, it's easy to write web applications because Django takes care of all the details of Hypertext Transfer Protocol, HTTP. And you can read documents, tons of documents, hundreds and thousands of pages, and write your own Python code to handle the HTTP. The problem though is while Django makes it so you don't have to read any of that, you do have to understand Django. And Django, to give you the kind of flexibility that you need, uses a very object-oriented inversion of control, a whole bunch of design patterns that make it so you don't have to write the whole application, but you need to plug your work into Django. So it's important for you to understand what the framework is and how it is that your work fits into it. So Mini-Django is the simplest possible Django that I could write. It's under 200 lines. The Mini-Django framework itself is only 200 lines of Python, meaning you can read it, you can understand it, and you can even change it and explore supporting additional features of HTTP. So we're going to both have a Mini-Django and a really simple Django-like application. So why do we use Django in the first place? Like I said, do you really want to read RFC 7231? It is pages, that's over 100 pages, and it's detail upon detail upon detail. If you start reading it, you will realize it's really well defined how browsers and web servers talk, but you really don't want to read it, especially when someone else has written all the code, and all you have to do is import HTTP request and response from django.http and then write a 4-line function that takes as its input an HTTP request and returns an HTTP response. And then in your code, you create the HTTP response and put some text in it and you return it. And then Django literally outside of your code does everything else. So Django takes this super complex task and hides it behind an abstraction. An abstraction is something you're sort of not supposed to look past. You're supposed to just look at the interface that it gives to you, and you're supposed to express your logic and then plug it in at the right place to create a rich and HTTP compliant web application. And Django handles all the details, and there's lots of them, thousands and thousands of little detail. But with all abstractions, it's a good idea to understand the shape of the abstraction that you're dealing with so you can kind of have some predictability as to when you make a change to your code, how is that? And then Django says, do this, override this method, override the query method, da-da-da-da-da, all that stuff. You have to kind of understand what's going on behind the scenes. And so my hope is that if you can understand Mini-Django, you'll have a much better chance of understanding the real Django. So in my class, I use this thing, I call it the big picture. And on the left side is a browser with a document object model that deals with HTML and CSS and JavaScript and intercepts user actions and then sends the request response cycle into a server running somewhere on the internet. There's Django and Linux, and there's urls.py and views.py and forms.py and templates.py. And literally the first half of any Django class I teach really is designed to understand this picture. And it's a little complex. So what I like to do is I like to take Mini-Django, which I've written, and the HTTP server part of Mini-Django is under 100 lines of code, meaning you can look at it. It's a web server that responds to a request and sends back a response. And then we have pseudo application code, the urls.py, which handles the routing activity, chooses the right view, and then sends the request to the right view, gets a response back from that view, and then urls.py forwards that back to HTTP server, which then formats it in the right way for the network protocol and sends it back to the browser. And if you look at how Django itself works, it's just a more flexible and more rich and more intricate version of this little thing that I call Mini-Django. So if you check out Mini-Django, you'll see that it really is just 4 files and some documentation. The run server.py loads the Mini-Django library and loads the path router in urls.py and starts the HTTP server. There always has to be a process listening on the port to accept the connections. The web server is the library, the framework. It is Django. It's just tiny, so I call it Mini-Django. It listens for incoming service requests in a Linux process or a Windows process. Then when it gets a request, it parses the network protocol part of that request. Then when it's got it right, it passes the request to urls.py for routing between the views. Then the view produces the HTTP response object, and then urls.py sends that back to the HTTP server, and then it sends it back to the browser when the HTTP server sends it back to the browser using the HTTP protocol correctly. The urls.py, much like any Django application's urls.py, it looks at a path in the HTTP request object and then chooses a view function. And views.py is a set of functions that capture the functionality of your web application. Each function takes an HTTP request as its input and produces an HTTP response for the output. So to get started, you can download the source code from GitHub into a folder using either get or zip. GitHub, if you look at the code button in GitHub, it gives you an option to download a zip, which means you don't have to install Git and you don't have to do a get checkout. And then you can just follow the README instructions. If you have Python installed on your computer, you say Python run server.py, and then you navigate to the localhost :9000 in your browsers, and you're interacting with this little server that's running on a process on your computer. Taking a look at the source code, the views.py looks a lot like Django's views.py, at least in the beginning in the simplest views, where each view is a function, takes as its first parameter a variable, I call it REQ in this situation, of type HTTP request, and is expected to return an HTTP response. So if you look at it, it creates the HTTP response object. Again, the definition of HTTP response came from Mini-Django. And the res.headers allows us to set headers. Then res.write creates the body of the response. And then we return that response, which then we turn back over to Mini-Django to send back. The urls.py in Mini-Django looks a little bit different than the urls.py in a real Django application, because I didn't want to create, if you look at the urls.py in a real application, it's really a table of routes, and I just made it an if then else so that you could see it's not that different than what the table of routes really is, and you might decide in your mind that this is a little cleaner and elegant. The purpose of urls.py in Django and in Mini-Django is to look at the path and choose a view and then cause that view to be executed. And you see at the end, if it can't find a view, it sends back a failure view with a 404 not found. So up next, we're going to do a simple demo of downloading, installing, and running Mini-Django. So here's the demonstration of Mini-Django for my Django for Everybody class. We're going to start by going into GitHub and taking a look at my Mini-Django repository. You see github.com/c/sev/mini_Django is where we find the code. And in here, we have a README and then 4 source files. And this README tells us where we're going to do. We're going to start by downloading this code and then running it. And we'll go through this in a bit. So there are 2 ways that you can install this. If you have Git, find some folder, do a git clone, and grab Mini-Django. If you don't want to install Git or you don't know how to use Git, you can just grab a zip file, because GitHub is really nice, and that's how we're going to do it. Under this code button, there's a thing called download zip, and so that's just going to download it, and it just downloaded it into my downloads folder. So I'm going to click and see, here's my downloads folder, and on Windows it's a little trickier when you go into your downloads folder. It hides this .zip. The Mac is pretty easy. I think on the Windows you kind of have to right click and extract it, but on Mac you just double click it and it extracts it into real files. So now we see the actual files, and so these files, Mini-Django README run server, they're all the same files that you got on GitHub. And so now you're kind of done with GitHub. Okay, so there's the downloads file, and now I'm going to start a terminal. And in Windows, this is like a command shell. In Windows, you would type CD to see the current working directory, and in Mac and Linux, you say pwd to see the current working directory. And my downloads are just in a subfolder underneath my home directory, users csev. And if I do an ls -l, you'll see that I've got that zip file that was downloaded, and then a folder with Mini-Django main. So I'm going to go into Mini-Django-main. And so now if you look at the working directory, you see I'm in my downloads folder. I'm in Mini-Django.main. And as a matter of fact, if I do an ls-l in this folder, you see the exact same files that you see here in downloads. And so I'm going to minimize that for now. And away you go. And so if we go back to the README now, it says Python run server.py. So I'm going to copy that. And so what this does is it starts the Mini-Django server. If this was Django on your laptop, you'd say Python manage py run server. If this was Django on Python Anywhere, you would go and reload your web server. But whatever this does is it causes it to start up and listen on a server port. So I have this thing starting on 9,000. Higher numbers tend to be used for development. Lower numbers like 80 or 443 are using for production. And now I can go and grab this URL, localhost 9000, and I can start a browser. Here's a little baby browser. Now I'm going to keep these up at the same time. Oh, come back. Okay, let's go back to my browser. Go back to this window, and I'm going to go to localhost 9000. As a matter of fact, before I do that, I am going to turn on the web developer tools and watch the network tab. And now I'm going to go to localhost 9000. Okay, it's all clear. Oh, wait a sec. I want to hide all that stuff. Okay, so what we have here is we have a, what? Something went wrong. I don't know what went wrong. Maybe it's doing a head request for all I know. Okay, so I've played around too long and something went wrong. I'll figure that bug out later. Okay, so now I go over here and I hit ask for localhost 9000, and it does a request. You can see it down here. Let's move this up a bit so I can see it better. So it does a request, and the response is this HTML, and I can see it in source code form, or I can see it in rendered form. And I can look at the headers. It sent these headers in, the request headers. So the interesting thing is you can see this debug. Let's make this just a little bigger. There we go. This thing just waits, right? Oh, let's go up to here. It waits, started the server, and now there's a process running on my computer that's hooked up to server 9000 waiting for something to happen. I'll show you this code in a minute. So this is just debugging. I wait for the next request. I receive a get, and that's the same as this get. There we go. That's this get to slash. It's an HTTP 1.1. It's a GET request. And then these are all of the headers that are being sent. And if you look down here at request headers, you see all of them, every one of them, cookie, pragma. Those are being sent to the web server. The web server is receiving them on a socket connection and then parsing that. And so then it runs the code. And this router, we'll talk about the router in a second. It says, oh, I got a slash path, which is slash is there's nothing here. It's after the 9000. There's nothing after the 9000. There's slash path. Then it goes to the view. And then it gets back from the view a response. Then it sends the response headers. The only one we're really changing is the fact that this is an HTML request. And then it sends 217 characters of the body output. So this is the body output. And the web server sent 200, I'm guessing that's 217 characters. And then it goes back up and waits for the next request. Now, it turns out the next request is rapidly forthcoming, and that's because it's requesting the favicon, okay? And the favicon is, it's trying to figure out what this icon is supposed to be. So if you look at like, let's go back to this. Here, you can see this DJ is a favicon, and the little octocat, that's a favicon, and it's trying to figure out what favicon to put on localhost 9000, but I don't have the capability to serve a favicon, so the favicon is a 404 not found. So it's like, hey, I want a favicon. Give me a favicon. My browser is sending to my server, give me the favicon. And I route the path to favicon, and it blows up with a 404. And if you look at the response, you see the response is this 404. Let's look at the headers. Look at the response headers. We got a response status of 404, and we got that it's an HTML page, and those are the response headers. But the 404 is the thing that tells the browser that I can't find this path. That's the path I've asked for, and I can't get it. And the browser is perfectly happy with that, and just doesn't put up a favicon for us. Okay, so now what we're going to do is we're going to do another request, and it tells us to add /DJ for E. And now it's still, this keeps asking for the favicon. Wish it would stop, but it doesn't. Maybe I'll add favicon, or maybe I'll have you add favicon support for it. So we receive the headers. We got a get for /DJ for E. So if you look here, let's go back to this get request. This is a get with a path of DJ for E, and then all the headers, of course. And we have a valid route, which you'll see this code in a second for the routing. It sends response headers. It says this is a text /plain. So if we look at the response headers, come back. If we look at the response headers, this is text /plain /UTF-8. So this web server on the left and the browser on the right are participating in a protocol. And again, there's all kinds of rules about the protocol. HTTP protocol. RFC. RFC stands for request for content. Okay, this is 7231. So this document right here tells us, like, let's go in this document and search for get. The get request. And the rules for what the get request looks like are here. So let's take a look. The head, I think the head is what, when it blew up, it was sending a head request because I was sort of typing and it was trying to look ahead. Yeah, it might be that I have to check what the head is, if it was a head. But let's keep looking for get. Let's look for an example get. Put. So again, I'm already on page 26. It doesn't make any sense. It's a mess. We don't want to learn how to do that. But somebody had to know how to do it. Now, I've been working with some of this long enough that I wrote this code without having to read this. The format of the headers, everybody kind of knows, and the format of the body, everybody kind of knows. And so I wrote this code, which I'm going to show you in a second, that knows how to do this. So let's get back. And so the body output, it sent 13 characters of body output. Let's take a look at the response. The response is a plain text. It's not HTML, so it's not formatted. That's why it's in courier format here. And so let's go back and go to, let me clear this temporarily. Go to JS free. Now this returns it returns a different status code. It returns a 302 status code, which is a headers. And so the 302 is the status code, and that's called a redirect. And then it has this additional location header. And so that location header says go somewhere else. Okay, I gotta go back. Where am I at here? I gotta find. So this is, where's JS for E?
Yeah, okay. So this is the JS for E. So it did a GET request for JS for E. Boom. Routed all the right places. Route to this path of JS for E in my views. And then it sent a response header which says, I'm going to send you a 302. And I'm going to send this additional location that says, go immediately grab this. And so the browser instantaneously went and grabbed the DJ for E and retrieved that, and that's what that found. So let's go back to the root again, clear our browser, and now let's look at an error. So let's just go to a URL that is just junk and broken, and like Django, what happened? Did I blow up my code? Oh, I was typing too long. Well, let's run it again. Address already in use. You have to wait a little bit. You got to wait because the process was connected to the port, and then the process died, and it tried to close it, but now it still can't get it. Sometimes it takes a few seconds to get it back. Don't worry about it. Address already in use. Don't worry about it. There we go. We're back. So now I got to go and I got to say missing, and now we get a 404. We got it. We sent a 404, and this looks kind of like the Django, but the key thing here is it returns a header of a 404, which is, I didn't know how to route this path missing, blah, 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 blah. And Django does kind of the same basic thing, right? And I put a dump of all this stuff just for yucks. And then I have a broken view, which I'll show you in a moment, broken. And this has a logic error in the Python, and it blows up. And the 500 error is the way that the server indicates to us that it did not get the right kind of response from the router or the view. Okay? So that is our widget. And let me take a look and show you some of the source code. Guess I'll make this bigger now. So again, I am in my users CSEV downloads Mini-Django main, and it's got the source code. And so let's start with the simplest file. And this is, in a sense, kind of like if you're developing Django locally, Python manage PyRun server. If you're developing in Python anywhere, this is like the reload application button. And we have to start this. This is a process that's going to listen on a port. And you do this by saying python run server.py. You can switch to a different port with a parameter. And then if you're going to auto-grade this in Django for everybody, you got to turn on autograder support. It adds a little extra line in there for autograder support. And so you've got to add this Python run server pi 9000 autograder. But if you look at this, it's sort of taken that first parameter for the port, and it prints a print statement, and then it's imported Mini-Django. Okay, and in Mini-Django there is a method which we will see in a minute called HTTP server, and that starts the server, and we pass into it the URLs, urls.py. We've imported URLs, and that is our URL router. That is our URL router. That is our URL router. And so we're going to run the web server, and then in the middle of that web server, it's going to route the URLs to our application. So let's take a look at the web server, the Mini-Django itself. You'll notice it's 174 lines. Okay, so in this, we've got a couple of things. We create some data classes, which these are just really lightweight objects. We have just some data in here, the method, which is get, the path, which is like /DJ for E, the headers, which is being incoming headers, that's going to be in a dictionary, and then the body, which is, if it was a post or whatever. The response, which is what we're supposed to produce and send back. We have an error code, which is 200 OK normally. We have some response headers, and then we have a response body. And we make a little method in here that basically is going to append to a list. So we're accumulating the lines, which we will then send back to. So these objects are the things that views will work with, the HTTP request, response, and etc. So the first thing we have to do is take the incoming request. And so the parsing of the request has to do with what the headers look like, what the body looks like. And it's pretty simple. The headers are a bunch of key value pairs with this colon pattern, and it followed by a blank line followed by the body. And so the code splits the incoming text that we've read from the input. Here, parse request, the read input. We break it into head and body, and then we split the header lines based on the rule, and then we send the headers back and we put them in the object, and then we return the HTTP request object. Response send, we'll come back to that. Here's a little patch autograder stuff. Here's the HTTP server. Okay, so what you see here is web servers have a thing where it makes a socket. That's like a file handle to the operating system that says we're going to exchange network traffic. It's going to connect it to localhost on port 9000. And then we're going to have listen. This 5 is the queue. So while you're processing one, the operating system, if another one arrives in that moment, it'll queue up 5 of them. And after it gets 5 that you haven't processed yet. But then what it does is we're going to have a loop, an infinite loop basically. We say waiting for the next response, and then we say accept it. And we get a socket, which is a readable bit of data, like a file handle at that point, one that you can both read and write. And then the address, which we're not going to really use. So once it sits in this for a long time. It's waiting for the next request. And then it reads up to 5,000 characters, decodes it because it's UTF-8 coming from the internet, and then gives us that in a big string. And we print the received headers, which is just a string at this point. And then we call parse request, which we just looked at, which breaks it into headers, turns the headers into a dictionary and has the body, figures out the method and figures out the path, and returns us an object of type HTTP request. Now, remember that 500 error? If we didn't get something, a parse request, remember I had that error happen. If we don't have the request that we got back from parse request, like it's a false or something went wrong, we're going to just go to the 500 error because that's the view fail. It says, I couldn't parse it, I'm going to give up. Otherwise, we got a good request, and so we're going to take the router, which is the first parameter to HTTP server, and that is a function, and we're going to pass the request object into the function and expect to get a response object back from the router. Now, if we're not getting a response object from the router, then we're going to blow up with a 500, and this is what happens when you see the broken, and we'll see that in the view in a moment. And now we got a response back, and it's got all the headers, response headers, it's got the response body, and then we send her back, and then we shut down the socket, and then we go back up and wait for the next socket. So it says waiting for next request. So it spends a lot of time waiting, then it gets some data, reads it really quick, processes it really quick, and then goes back and waits for the next request. Now if we take a look at response send, this is again doing the HTTP protocol. We send the headers in the right format, then we send a blank line, and then we go through and read the body and send all that out, and then we close it all out. Okay, so that's response send. HTTP server, response send, and then the last thing we've got is this view fail method, and that's called for like a 404 or a 500, and it's got the request in case we need to look at it. We're dumping the request actually, and then a failure string, which is kind of a, that's just some debugging additional clue as to what might have gone wrong. We're printing. Now we're logging this. You'll notice that we always have this logging. So we're seeing all these print statements coming out to us. That makes it easy for us to debug it. And you might even blow this code up once in a while and you get tracebacks in here. And so all this does is it prints out the page. Let's go back to the page. If you say missing, you get a 404 not found. This is just Pat printing that whole thing, what the response code is, the dumping it, making it pretty. And so this is a way for you to debug when things are going badly. And you can either get a 404 error, or if your view is broken, you get a 500 error. Okay? So now let's take a look at this router. Okay, so router is a parameter. It is in the file URLs, and it's as the function called router. So let's take a look at the file URLs. And so this is similar to Python's Django urls.py, and we get the print statement routing to path, right? So that it has got the path out of the incoming request. If it's a slash, we're going to run a function out of views. See, it doesn't import of views. There's a function named root in views. And if it starts with slash DJ for E, we're going to call the DJ for E view. If it's equal to JS for E, we're going to call that view. And if it's slash broken, we're going to call the broken view. Now, if you look at Django's urls.py, they put all this into an array of tuples, basically. And in that array of tuples, it's more complex than this. But I figured I would just make this a simple pattern of if, elif, 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 just because that's all that array is doing if we're going to be very simple. Now, if we don't see one of these paths that our application knows about, we drop into this else, and then that's where we send the 404 not found. Okay, and so let's take a look now at views.py. And this is a views, and we're going to import Mini-Django, and that's the HTTP request and response. That is these two data classes, which are really kind of very lightweight objects. So lightweight syntax to build objects quickly. And so the parameter to our view is an HTTP request because the framework has built an HTTP request and has passed it to us, right? And we are expected. So if you've been newbie to Python or been doing Python a long time, this is Python type extensions. I think it came in Python 3.5. The parameter name is request, colon, and then the type name. This is the expected type. And then the return name, that just says that when we return from this function, we're supposed to send back an HTTP response. So you could do this without this sort of syntactic fluff, but boy, it sure helps for me to talk to you about what the parameter and return value are supposed to be, because that's what that line is really saying. Okay. So our contract is we're supposed to return an HTTP response. And again, that's an object defined by the framework. So we're going to create one. We're going to set the headers. The headers are just a dictionary. So they're key value pair, and we're going to tell it the content type. And again, you can go look up what content type is in the documentation. And then we do a series of writes. And at this point, in the response object, if you go back and look at it, that's accumulating a list of strings. And we're not actually sending the data at this moment. We are accumulating a list of strings, and then we have constructed and filled up this response object, and we send it back. Okay, and so if you go in here, it's also being returned back up through urls.py, back up into, where's the router? Come back, there we go. The router is urls.py. We are getting back an HTTP response. We're checking to see if it's a good one. If it's not good, we send a 500. If it is good, we, actually I should make that be, well, okay. So I think I got to put a little extra line of code in here. So by the time you're looking at it, I think this is supposed to, yeah. I'll put some code in here. Okay. So then we send that response back. So we're here in the views, we are returning the response. It works its way back up through the URLs, back into the Django itself. We get the response, and then we send it back to the browser. We're almost done. So we have a series. This is our application code, right? The URLs is just kind of to get us where we want. The DJ for E is sending back a single line of text. The JS for E is sending a redirect, and so we're telling it to send a code of 302. That's called a temporary redirect. And we're adding a header called the location, which is where we want to redirect to. So we return this, it goes to the browser, and the browser immediately comes back and comes back to this DJ for E. And that's what you see when you go to /J. Here, let me hide this. Boom. That's what you see when you go to JS for E. So first you see a 302, which sends back a location to DJ for E, and then the browser, in a blink of an eye, without waiting for you, does a GET request to DJ for E, because that's what it was told to do. So you return this, goes all the way back to the browser sees the 302 redirect, sees the location, and then comes back in and reads this code, and that's how that works. The only remaining view is the broken, and in this, it's not going to return an HTTP response. All these other ones make HTTP responses and return them. This is just returning a string by mistake. It turns out, I think in Django you can return a string, and it kind of makes an HTTP request for you. But I was more interested in causing a 500. Or return a string, the path returns that to the framework receives a string as the response, and then it's not an HTTP response, so we get a 500 error. And so if I go to /broken, let me clear this, boom, I get a 500 error. So the 500 error not only is a 500 error, but there is a response involved in there, right? And so there's some HTML that comes back with all that stuff. And so there we go. I'm sure you have questions, but you can look at all this code and you can figure it all out and enjoy it. So again, this is about the Mini-Django web server, like the smallest approximately Django web server that I could build so that you can read and even play with it and put print statements in. And again, this is part of my Django for Everybody class. Cheers.